Welcome engineers to my guide for MArmOS, and today we're going to be talking about shapes and how to define them. A disclaimer though, this is my personal interpretation of how the script works, and based on different arms that I have made that have worked without flaw, I believe that this is a correct view of the script. Now there are other ways to view the script I've noticed in the guide, but we could touch on that in a later video, or I could just simply explain that in the comments below. But I feel like that the way I do it is the most simple, considering the type of person I am, thinking hard, so I make simple. I want to start with the example in front of us. This shows the orientation rotor, or the axis joint. This is not a proper term, this is something that I use to help me define my shapes. So from the axis joint, we go up one block in the Z location. Now, the axis joint is never counted in calculations for a solid, so this is actually 1Z. Moving on to our second example, we have the axis joint followed by one block in the Z and one block in the X. If we follow this logic from the first example, this would be 1Z and 1X. However, everything in the X plane is counted, so this is also an X, along with a Z. So when looking at this example, we have 1Z, 2X. It would be written as 201. Before we start this next example, if you have any questions, please leave them in the comments below. I will do everything that I can to answer those questions for you. Starting this next example, we have our axis joint followed by one block above it, 3 to the left, and with our orientation being 0 here. From this point of view, everything to our left is positive X. We now have one joint followed by another block. With the idea of the shape that we're looking at, we can start to formulate what our shape dimensions will be. We're looking at what is called a 3D object, and we're going to follow this along just like it's a skeleton. This is something that the author of the script had pointed out in his guide. Starting from the axis joint, we have 1Z, 3X, giving us a total of 4X, followed by 1 to the Z, and another to the Z here as well. In this particular example, there are no breaks in the shape going forward. Now this is only true if this is the end of our shape. We'll cut more into that in a moment. So when we write this out, we can actually go 4X, 1 for the orientation section, plus 2. This is a simple way of understanding how the arm works by writing 1 plus 2. We have our 2 points in the Z here. We have our 1 point into the Z here. And again, this example is only if this block that I'm going to paint red just now is the end of your arm. This is what makes shapes so complicated to understand. Moving on to the next part, we have our axis joint followed by one block to the Z, a piston, another block on the X, 2 more blocks on the Z. Now pistons, they take 2 blocks. However, they're a special type of block, so this is only counted as 1. So if we look at this, we have 1, 2, 3 in the X, 2 in the Z, and 1 in the Z. Again, this example is only valid if this is the end of your chain. Now to write this, we very simply come in 3, 1 plus 2. And now we have our shape defined. Again, this is the end point in this shape. This is why we have the formula that we do, and it's only because of these endpoints here. If this goes further, this can technically change. To explain that, let's build a complicated shape. I'm going to start off by placing down a couple blocks, and then we'll come back and we'll talk about it. The example that I have in front of you guys right now is a very typical thing used in making arms. We have our axis joint. We have a joint to spin along the x-axis. We have another joint to spin along the Z, giving us left, right, and roll here. To define this, we have to combine everything that we have learned from these previous two examples into this with an addition of how to define where shape breaks are. Now, to know this, we have to know the endpoint of our arm. The endpoint of our arm, we will more prominently pronounce that by placing this inverted X here. I decided to add an extra block in so that you can more visualize what the end of the arm is by adding in this welder unit here, or grinder. Oh, my bad. I'm doing this in the morning. I haven't been up very long, so I apologize there. Now we have our start point and our end point. This is where we can start determining what shapes are broken up and when they are not. For example, we have our axis joint, which should be blue. Why are you not blue? Going into the Z. We have another joint going into the X, followed by 3 blocks, going into another joint, going into the end of our arm. This is very important that we know the end of our arm. This determines how we will go forth from here. For example, this can be viewed in many different ways. To get the shape of this object, this is why I said earlier, it comes down to personal interpretation of how the script works and whether or not your interpretation is true when it comes to this situation. Here, let's define this at how I would define this. I will call this block here a break. Why do I call it a break? We have 2 joints intersecting in one area, so this is the breaker block. This block separates one shape from another shape. The idea would be true if we continued along the arm. Every breaker block will start a new shape. Now, to define this, we need to do the solid for the axis rotor, which is 1Z. We have simply finished that shape in this example. Now, to better understand the flow of how this next shape works, I have colored every single block the same color, because now we are only working with one additional shape. Why? It's because this joint, coming into this joint, which would normally create a break block, does not, because it goes into the end of the arm. Again, this is only true if you are moving into the end of your arm. Our first shape here from this breaker block, we need to count over the next sections. One thing I'd like to point out, that anything that you consider the end of your arm is not counted in the formation of a solid shape. So with that knowledge in hand, we can go 1, 2, 3, 4 on the X, and 1, 2 on the Z. Very, very simple. In theory, you could actually just count all of this. I often do, because why not? This would give us 1, 2, 3 in the Z. So to write that, we simply come here in the 4 to the X, and then we put in 3 to the Z. Hopefully this helps you all better understand how to formulate shapes for MArmOS. I know this can be a very complicated thing to understand. I say that only from my point of view. I know a lot of my viewers and subscribers are way smarter than I am, and they understand these things far better. If you have a hard time understanding these scripts and how this exactly works, using my point of view will help you complete any project using this beautiful script without issues. Yes, there could be a few things off, but it's all been tested to work perfectly, as shown in some of my Let's Play videos where I actually build these systems and use them in everyday tasks such as welding ships, grinding things down, etc., etc. One last thing I'd like to say, if this video has helped you in any way, please leave a like, comment below. Let me know what could be improved on this video. This is an absolutely amazing script. I feel like a lot more people should be using it than there are. And the way it is written and the way you have to go about it is very daunting. It turns a lot of people off. I have simplified this as much as possible that within the allowance of the script. And last thing, if you've enjoyed this video, please consider subscribing. I have lots of Space Engineers content out already, and I have lots more planned to come. And as always, my friends, when in doubt, crowbar